The second explosion followed soon after, and was even larger, blasting an estimated 22,600 metric tons of mud and rock into the air. This material within a few seconds fell back to the ground in a 130-meter or 427-foot radius, accumulating to at least 30 centimeters thick. With the volcanic vent now cleared of debris, the third explosion, which is shown in this footage, merely involved a tall water vapor plume with minimal if any fine particles present. As a result of this unexpected series of blasts, a 500-meter or 1,640-foot exclusion zone was declared in all directions around this crater. A VEI-1 What had just occurred was a series of phreatic eruptions, which I estimated to have just barely surpassed the threshold for a volcanic explosivity index of a 1. Multiple sources are claiming this at Suoh's first eruption in 91 years. However, many of these sources get a few notable details straight wrong, as Suoh has been far more active than this. Suoh has not only erupted in 1933, but also erupted, albeit with fairly weak explosions, in 1994. Additionally, according to Alkautsar Purnama Agung, a geoscientist, the locals reported two other small phreatic eruptions previously occurred during January of 2021 and May of 2023. Per Agung, evidence seems to support that both of these reported events were indeed phreatic eruptions rather than hydrothermal explosions, with Google Earth imagery even appearing to show dead vegetation as a result of the 2021 eruption. So, why did this eruption occur, and what might happen next? To answer these questions, I need to first explain why the Suoh volcano exists in the first place. Geologic setting offshore of Sumatra, which is home to 60 million people, there is a major tectonic plate boundary. There, the Indo-Australian plate to the southwest is colliding with and subducting underneath the Sunda plate. The oceanic crust from the subducted Sunda plate then experiences partial melting, allowing for batches of magma to intrude into the crust and form a chain of volcanoes, like Suoh. However, the aforementioned collision is not occurring directly head-on, causing some horizontal motion to be generated. The Great Sumatran Fault, a 1,900-kilometer-long strike-slip fault similar to the San Andreas Fault, formed as a result of this strain partitioning, creating a line easily visible from orbit. Since this fault acts as a path of least resistance for magma to intrude into, almost all of Sumatra's volcanoes exist on or adjacent to this fault line, including Merapi, Kerinci, Dempo, and Suoh. More specifically, Suoh exists in a stepover or pull-apart basin of the Great Sumatran Fault. A stepover forms when strain at the end of one strike-slip fault transfers to a parallel fault, causing the area to spread apart over time. Whenever a major earthquake occurs, the additional spreading can sometimes allow for magmatic heat to reach underlying groundwater, which can then subsequently flash to steam and explode. In the case of Suoh, it appears that not only had increased heat been transferred cause of the eruption into the groundwater underneath Kramakan crater, but also that a thick caprock of mud, sinter, and sands had developed on top of it. Thus, when the flash to steam occurred, pressure built up until it exploded upwards, producing today's eruption. It is possible that more smaller current outlook phreatic eruptions will occur from the same crater or event directly west or east of it. However, if and when this will occur is uncertain due to the unpredictable nature of phreatic eruptions, since they don't directly involve any molten rock. As a final note, I would like to thank Frida Dunn for increasing their membership tier on this channel